Hello everyone. My name is Cristiven Wowor with NAM 251011060005. I will present material about computer logic. Behind every smart gadget, there are three basic logic gates that govern everything. Let's explore. Logic gates are the basic building blocks of digital circuits. They process one or more input signals to produce a specific output based on logical operations. The main types of logic gates are AND, OR, and NOT. The AND gate produces an output of 1, true, only when all inputs are 1. Gives an output of 1 if at least one input is 1. The output is 0 only when all inputs are 0. Has one input and inverts it. If the input is 1, the output is 0. If the input is 0, the output is 1. The basic logic gates, AND, OR, and NOT, play a vital role in digital systems. Each gate performs a unique logical operation that helps process information in electronic circuits. The AND gate requires all inputs to be true for the output to be true. The OR gate produces a true output if at least one input is true, and the NOT gate simply inverts the input signal. Together, these gates form the foundation of all digital logic used in computers, processors, and various technological devices. Hello everyone. In this video, we're going to learn about the rules of inference, logical rules that help us draw valid conclusions from given statements. We have modus tollens. If P implies Q and Q is false, then we can conclude that P is also false. Next, modus ponens. If P implies Q and P is true, then Q must be true. Then comes simplification. If P and Q are both true, we can conclude that P is true. After that, conjunction. If P is true and Q is true, then together they form P and Q. Next, disjunctive syllogism. If P or Q is true and P is false, then Q must be true. Now let's move to the right side. Disjunctive amplification says that if P is true, we can conclude P or Q. Then, contradiction. If not P leads to a false statement, then P must be true. Next is conditional proof. If P and Q are true, and P implies that Q implies R, then we can conclude R. Then, proof by cases. If P implies R and Q implies R, then P or Q also implies R. And finally, law of syllogism. If P implies Q and Q implies R, then we can conclude that P implies R. In conclusion, the rules of inference are essential tools for logical thinking. They help us draw valid conclusions from statements that are known to be true. By using these rules, like modus ponens, modus tollens, and simplification, we can reason step by step with accuracy and clarity. These rules are not only used in mathematics or computer science, but also in everyday decision-making and problem-solving. They train our minds to think critically, connect ideas logically, and find truth through reasoning. So, mastering the rules of inference means learning how to think clearly, argue logically, and make better decisions. Thank you for watching, and keep practicing your logical thinking.